Hello everyone, in this video we are going to see about the threads and its types. Let us see first of all what is a thread. Thread is a lightweight process. And what does the process mean for a system? A process is a unit of execution. Whenever you give any program or any process to the system, the process is divided into many multiple sub processes, and those processes are divided into so many jobs, and that into task, and that into threads. So thread is the minimum unit of process which can be solved by the system. So it is also called as a lightweight process. Let us see the different types of threads. And we have user level threads and kernel level threads. What do you mean by user level threads and kernel level thread is, when you say the user level thread, it can be created by the application program. So the user level threads are implemented by the user level software. That means we have some commands to create the threads. Those threads will help to solve the problem of the user. The user level threads are basically created and implemented by the thread libraries with the OS provides. So the operating system has some libraries that is called built-in functions. Those built-in functions will help us to create the different types of threads. That is the user level thread. And it is faster than kernel level threads. It is basically represented by the program counter, stack, register and PCB. So what does it mean is, as we know that the user level processes are simple processes that can be done faster. So user level threads are faster than the kernel level threads, and it is represented by the program counter, stack, register and PCB. Means every thread has its own actually, as we are just seen before, every program we give to the system will be converted into process, and those processes into many jobs and tasks and finally threads. So every thread comes from a particular process or the program. So it has some program counter. So that counter is also attached to the user level threads, and it has some stack to hold some data in the memory, and it has some registers to do the work, and it also store the work. And as the PCB, that is the process control block, the thread can refer to the number which it comes from, the which process it comes from. That means we have seen that thread comes from the process, so it has the identification of the process, which is the PCB, process control block. And then we have some example here. User threads library includes POSIX threads, Mac C threads, etc. And let us see what is the kernel thread. The kernel thread means, actually the kernel means the core of the operating system. The center of the OS is the kernel, and it has some threads to do the system level processes. They are called as kernel level threads. In terms of operating systems, basically the threads are the unit of execution within a process. So it is a unit of the processes. The kernel level threads are directly handled by the operating system, the OS, whereas the threads management is done by the kernel. So we have OS is the main thing, and kernel is the center of the, that is the nucleus of the OS. So here they are dividing the work into, the threads are handled by the OS itself directly, whereas the management of the threads, that is how to store, where to store, how to get back, how to access the registers, those things are done by the thread management system of the software. And then in the kernel level threads, each thread is self-organizing, and the kernel provides each thread with its own context with information about the thread's status, such as its name, group and priority. So what does here mean is, the thread, it as has come from a process, it has some name, it has some identity, it has belong to some group, and it has some priority, when to do it, when not to do it, which is the highest priority. So those things will be attached to the thread. Okay, so now here each kernel level thread is self-organizing, and kernel provides the, that is the context, that is in which context it has to work. So that is all done by given by the operating system. Okay, and then example of kernel level threads are Java threads and POSIX threads, etc. So these are the basic definition of the user level and kernel level threads. Let us see the difference between the user level thread and kernel level thread. So we have some different parameters on which we divide or which we differentiate the user level and the kernel level thread. So here the first is implemented by. The user level thread is implemented by the user. That means the user can use some command by from the application software. Whereas in the case of kernel level threads, kernel threads are implemented by the operating system. That means OS has some system utility commands that helps to implement the kernel level threads. Next is the recognize how the threads are recognized. The operating system does not recognize the user level threads. That means the OS always recognize the kernel level threads, whereas it is not concerning about the user level threads. That means the user has to create, manage, and they have to run the whole thread management system. But in the case of kernel level thread, the OS recognizes the kernel threads. The implementation, how it is implemented, implementation of the user is thread is very easy, whereas as it is obvious, the implementation of kernel thread is complicated because it has so many system things to do. So we have few more differences, and the next difference is based upon how the context switch time. We know that every thread or the process has its own context to work. When it changes the context, it has to do some housekeeping operations. In the case of thread, it is usual level thread, it is less because it is a simple thread which is not complicated, which also consumes less context switch time. Context switch means moving from one situation to the other situation, whereas in the case of kernel level threads, the context switch time is more because it has to deal much with the system utilities. The fifth difference is the hardware support. Context switch requires no hardware support. That means user level threads are done by the software itself, whereas the kernel level threads need some hardware support. And regarding the blocking operation, if one user level thread is blocked, then the entire process will be blocked. We know that every process can have thousands of threads. Even if one user level thread is blocked, the whole process is being blocked. Whereas in the case of kernel level thread, the performs a blocking operation means then another thread can continue the execution. That means it never care about the any block in any of the kernel threads because the system has its own way of doing the operation by the kernel threads. So the next differences comes with the parameter multi-threading. So the multi-threading applications cannot take the advantage of the multi-processing. That means in the case of user level thread, if having multiple threads doesn't mean multiple processing, because for one process only we have so many threads. So in the case of user level threads, multi-processing means many processes having multiple threads cannot go together. But in the case of kernel level threads, kernel level can implement the multi-threading operations because as we know it is a system oriented threading operation. System can have all the facilities to do the multi-processing. And the next is the creation and management of the threads. User level threads can be created and managed more quickly because it is simple, whereas in the case of kernel level threads it takes more time to execute and manage. Then the next one is the operating system. Any operating system can support the user level threads because we have the system commands. We have the application software commands to run all the operating system commands. Whereas in the case of kernel, there are operating system specific. That means it depends upon the various operating system. For one operating system there may be different command, for another OS it may be different. So it has different it is not specific to the operating system user level threads, whereas kernel level threads are specific to the operating system. And the next is the thread management. The thread the library contains the code for the thread creation, message passing, thread scheduling, data transfer, and the thread destroying. So the library can create the thread, it can manage, it can pass message between the threads, and can delete the threads also. All these things are that's called thread management, can be done in the user level threads. Whereas in the case of kernel level threads, the application code does not contain thread management code. It is merely an API to kernel mode. The Windows operating system modules uses this feature. Okay. So now in the case of kernel level threads, it merely uses an API. API is the application program interface, and the Windows operating system makes use of these features. So So next difference comes with the next parameter, the example are the POSIX threads and the Java threads. In the case of a kernel, it is the window Solaris. And the next is the advantage. There are many advantages of the user level threads. One by one we'll see. The user level threads are simple and easy to create. They can run on any platform. They perform better than kernel threads since they do not need need to make the system calls to create the threads. In user level threads, switching between the contexts is very easy. So all these the things we have just seen before, they are collectively given as an advantages. In the case of kernel level threads, scheduling multiple threads that belong to the same process on different processes is possible in kernel level threads. Okay, that means a process, the thread may belong to different processes. That means there is a multiprocessing technique, and multi-threading can be there for kernel routines. When a thread at the kernel level is handled, the kernel can schedule another thread for the same process. That means for the same process, as we seen these points just before, so these they can have their own type of threads to do the different operations. That means parallelly different threads can be scheduled. So next is the difference as the disadvantages. This multi-threading applications on user level thread cannot benefit from multiprocessing. If a single user level thread performs a blocking operation, the entire thing is blocked. And in the case of kernel level threads, transferring control within the process from one thread to another thread necessitates a mode switch to the kernel mode. That means just you have to switch from the user mode to the kernel mode in order to do the operation. Kernel level threads take more time to create and manage the threads. And memory management, in user level threads, each thread has its own stack but they share the same address space. But in the case of kernel level threads, they have own stack as well as the own address space. That means the address space is not shared between each other. That means when it is not sharing the address space with each other, there will be some complicated work. It has to maintain its own separate address space. As we know that address space is a collection of addresses. And then the next differences is by the fault tolerance. As the name implies, when any fault occurs, how the user level thread is going to tolerate or the kernel level thread is going to tolerate. In the case of user level threads, the fault tolerance are less than the kernel level threads. If a user level thread crashes, it can bring down the whole process. That means if one thread crashes, it brings down the whole process itself. But in the case of kernel level threads, if one system fails or if one thread fails, it does not affect the others. Everything can go in their own way. And next is the resource utilization. So resources are all the memory spaces, input memory, the hard disk, the clock, everything is the resource. So in this case of resource utilization, user level threads don't take the full advantage of the system resources because it is a user level thread only. It need not require all the system resources as they do not have the direct access to the system level features like the IO operations. But in the case of kernel level threads, it can access the system level features like IO operations, so it can take the full advantage of the system resources. Because it is a kernel thread. Kernel comes from the operating system. So OS is depending upon the system. So naturally it can use all the system resources. And the last is the portability, which implies the user level threads are more portable than kernel level threads, because as we know that user level threads are implemented by the application software, by the software commands. So we can take this commands and we can execute the command in any system. It is called as portable. Whereas in the case of kernel level threads, they are less portable because they are dependent on the system. So they are not much portable like the user level threads. These are all the differences between the kernel level threads and user level threads. From these points I have just discussed, we have discussed before, we will be able to answer some 2-mark questions based upon the definition of threads and how the threading is done and how the each and every point can be asked as a 2-mark question, as well as we can also get some 1-word questions from these topics which are discussed earlier, and also we can get a full 15-mark question, which is a bigger brief answer by discussing all these points what we have discussed so far. So I think it is easy to follow, and thanks for watching.